Hi, I'm Young Kim, a research scientist at Naver AI Lab. I will introduce our project on leveraging pre-trained language models to streamline natural language interaction for self-tracking. This work was done in collaboration with my colleagues Sungdong Kim, Minsuk Chang, and Sang Lee. Self-tracking is a prevalent practice with a long history. People often keep journals to record their activities and reflect on their past days, or to track habitual behaviors visually. Self-tracking can be defined as a systematic and iterative process of collecting, exploring, and reflecting on the personal health and activity data. This research particularly focuses on the data collection aspect of self-tracking. Nowadays, we see many digital tools for self-tracking, which listen to natural language queries describing activity logs. For example, we can log our water intake on a smart speaker or record physical activity on a smartwatch. It is important to be able to extract structured data points from natural language queries because these data can be further used for various components of self-tracking, including data visualization, contextualized intervention, or even sharing data among different platforms. Unfortunately, the existing self-tracking systems largely depend on bespoke and rule-based natural language understanding. For example, given an NLU for food tracking, the system may not understand queries for productivity. We need a new implementation that expands rules to cover a new topic. In addition, existing approaches are usually not robust to individualize the phrasing patterns, especially if the pattern is out of the developer's anticipation. Although neural network-based models tend to work nicely for many NLP tasks, training models in the self-tracking context is not easy. There exist a number of different topics in self-tracking, as well as a wide variety of data schemas for each topic. Considering numerous different instances of NL queries, it is overwhelming to collect a sufficient amount of training data set. So in this work, we aim to build a unified NLP framework that can understand natural language queries in a broad range of topics, be easily personalized to individualized phrasing patterns, and that it can build without a lot of training data set. Here we introduce a novel NLP task for understanding self-tracking queries. Given a natural language query and a data schema, the analyst should extract a subset of field values. In this example, the query specifies 2 of the 3 data fields of the schema. To effectively resolve the task, we incorporated pre-trained large-scale language models such as GPT-3. As these models have learned a broad space of common sense, egocentric phrases, or synonyms for many keywords, their knowledge is very relevant to self-tracking scenarios. Here is an anatomy of zero-shot learning of the task on GPT-3. We feed the data schema and the input query to GPT-3 to extract the structured data. Since self-tracking is an iterative process, for the second data entry, the system can use the prior log as a one-shot sample. The model may become more robust as the user has more examples, but it may not perform well when there are no prior entries. Our main idea is to transform the target task into 10-shot learning using synthetic source samples. These samples consist of synthesized entries in various self-tracking topics. For example, the system grabs 8 samples from the source inventory to complement the user samples to guarantee 10 samples in a prompt. To create synthetic source samples, we first manually created 24 speed tracking schemas referring to the self-tracking literature and app surveys. We then randomly generated 504 sample instances in these schemas. After generating natural language queries that describe these instances using GPT-3, we inspected each case and corrected mismatches between the query and the instance. To assess the effect of prompt augmentation, we conducted a preliminary evaluation using the source samples. We extracted one data schema at a time and treated it as a user schema. We then iterated over each sample as a test case, treating other samples as prior entries of the user. As baselines, we tested pure zero-shot learning with neither prior entries nor prompt augmentation. As in-context learning cases, we tested 5 different scenarios with prompt augmentation, from 0 to 4 prior entries of the user. These settings simulate a user collecting data over time. We investigated the joint goal accuracy and F1 score for closed-ended fields such as numbers, short-form text, or multiple choices. For bus metrics, the prompt augmentation significantly boosted the performance, even in zero-shot. Also, the performance tended to increase with a few more prior examples. For open-ended text fields, we calculated BLEU4 and RUGI-L scores as performance metrics. We observed the similar boost in performance as the closed-ended fields. Now we'll discuss the results focusing on how HCI can play the role. Although our approach showed promising outcomes, the joint goal accuracy indicates that more than 1/3 of the tries may contain erroneous partial results. Apart from improving the model performance, we should consider involving user interaction methods to address the erroneous cases, since there are no 100% perfect models. For example, error recovery interaction methods such as rollback buttons are required for user interfaces. Also, we can make the system nudge the user to provide several example queries before the first use of a data schema for calibration. We note that the proposed task can be addressed by multi-turn conversation because it is an extended form of dialogue state tracking. We may design a conversational agent to guide the user filling out the information according to the data schema. When the user provides only partial information of the schema, the agent may ask back to provide the rest of the information. Such an approach would be effective for voice UIs. Now I summarize this work. In this work, we introduced a novel NLP task for self-tracking, along with a framework that solves the task. The preliminary evaluation suggested that augmenting prompts using synthetic samples can boost up the task performance, and the performance tended to increase with more past entries of the user. In closing, we call for both NLP and HCI researchers to collaborate in the field of self-tracking to design effective natural language interactions which are both performant and usable. For more information, please refer to our paper. Thank you for listening to this talk.